Right, grade 10s, we are at the end of our types of functions. We've done the straight line, the parabola, the hyperbola. This video is going to look at exponential functions, and then after that, in our next video, we're actually going to combine these, and you're going to see more than one given to you on one Cartesian plane, and we're going to have a look at how to answer those. But before we get to combining, let's spend some time focusing on this exponential function. Okay, this one is so relevant in our lives today. If you think about things like growth, people who study bacteria, or when there's a new virus that comes out, a lot of the time things are happening in this exponential growth pattern. And these graphs are actually very applicable to our daily lives. Let's take a look at the overview of what we need to know about these types of graphs. Okay, first of all, we are given this standard form. Y is equal to a times b to the x plus q. So whenever x is in the exponent, then you know you're dealing with an exponential graph. Okay, there are a couple of things that this standard form tells us, all right? And the first thing is this b value here helps us to understand the shape. Okay, so b is going to tell us about the shape. Now, there are two things that we need to know about b. Either b is a whole number that's bigger than 1, okay, and then we'll see an increasing function. All right, or we can end up with b that is actually a fraction between 0 and 1. So in other words, if it's a half to the power of x or a third to the power of x, then what you'll see is the shape is actually a decreasing shape. All right, so the b value tells us quite a bit about this. So if you look at the one that's sitting here, this one is increasing, which means that the b value is definitely not a fraction smaller than 1. It is a number bigger than 1 because it's increasing there. Okay, another thing to look at is this a value here, and a is linked to the steepness of a graph. Okay, now if a is positive, there's so many variables here, but let's just look at them one at a time. If a is positive, remember in maths we write it like that, then the graph is going to be above the asymptote. Okay, so if you look at this one that we've got here, the graph is above the asymptote, so a is definitely positive there. Okay, if a is smaller than 0, in other words negative, then the graph is going to be below the asymptote. Okay, and then the other thing that's worth noting is that the greater the a value, the steeper the graph. And if you think about it, it totally makes sense. Let's say this graph here is 1 times 3 to the x, okay? If I start multiplying that by an a value here, let's say like 10, this graph, suddenly all of my y values are going to multiply by 10. So something that was down here is going to go very high up. Now my graph is suddenly going to go very steep. Okay, but it's just important to know the increasing and decreasing, very important, and is it above the asymptote or below the asymptote? Okay, this greater the a value helps when you're given multiple graphs and you need to match an equation, but in general you'll start to see this one is actually quite logical. Okay, intercepts, you can have x and y intercepts depending on where your asymptote sits. So to get an x-intercept, we let y equal 0, and to get a y-intercept, we let x equal 0. Okay, and that's just the points there where it cuts the axes. And then there is just one asymptote in an exponential graph. It's a horizontal asymptote. So that means it only cuts the y-axis, which means it's a y line. So whatever that asymptote is, we'll then write it as y is equal to. In this case, we don't know, so we're just going to take it from the equation right here. Y is equal to q. Okay, so in our equation is a wealth of knowledge. X in the exponent. A tells us about how steep the graph is and whether it sits above or below the asymptote. B tells us whether we are dealing with an increasing or a decreasing graph. And the Q value tells us where the asymptote is. Okay, domain and range. So domain is the x values. If you look at this graph, it goes on forever in the negative x direction and forever at a very steep angle, but forever in the positive x direction. So our domain, our x values, are always defined in an exponential graph. Okay, but range is a different story. In this instance here, everything is above the asymptote. Okay, so we can then say y is an element and it's from the asymptote all the way up to infinity. Remember that it may not equal to the asymptote, eh? So that's why we didn't use a square bracket there. It's definitely a round bracket. Okay, if you prefer to write it in the inequality notation, then you'll say it's between q and infinity. All right, sketch the graph of f of x is equal to 2 to the x minus 2. So here I've got my system of axes. I'm going to pop some labels on there. That's a y-axis, and that's an x-axis. Okay, now what we want to do is we want to pop in the things that we know. Okay, so I can see here, this is the b value. B is a whole number, so the shape is going to be increasing. Okay, there isn't technically an a value there, but what it does tell me then is that this is positive, so it's going to be above the asymptote. And then finally, the q value here is the asymptote of this graph there at minus 2. So we're going to pick up a ruler. So important to use a ruler. And there where y equals minus 2, we are going to plot using dotted lines this y asymptote. Okay, so there we go. Y is equal to minus 2. Don't forget to label that. You don't want to lose any marks. Okay, and then we want to plot some points. So let's work out intercepts. Okay, so to get an x-intercept, we are going to let y equal 0. So in this equation, remember that we are allowed to say that f of x represents y. So we're going to say 0 is equal to 2 to the x minus 2. Now we want to move this minus 2 over. So we'll end up with 2 is equal to 2 to the x. Okay, and then because this is an exponential equation, if the bases are the same, I'm allowed to drop them. So on the left-hand side here, I've actually got 2 to the power of 1. Okay, it's not written there, but I should know that. And so that helps me to see that x is going to equal 1. So that's going to be one of the points there that I plot. Okay, remember, if you label your axes, then technically your coordinates are already labeled. Okay, to get a y-intercept, we want to let x equal 0. So we're going to say here y is equal to 2 to the power of 0 minus 2. Please be careful here, grade 10s. 2 to the power of 0 is not 0. Remember, we learned that anything to the power of 0 is equal to 1. So it ends up being 1 minus 2, which is minus 1. Okay, if we made this 0, if we made that mistake, we would have ended up with an answer of minus 2, which is the asymptote. And we know this thing is not allowed to cross the asymptote. Okay, so there's my second coordinate. And now I am ready to plot this graph. Okay, very important to label things. I have labeled my axes, so technically you don't have to write these down. But it is nice to label your graph there. Okay. Something worth noting is if I worked this out and saw I didn't have both an x and a y intercept. Okay. Picture with me if we were to move this asymptote up 3 places. So let's pretend they asked us to draw the graph 2 to the x plus 1. Okay. That would be us shifting everything up 1, 2, 3 places. So the asymptote would shift 3 places up. And that would be here at 1, y equals 1. Then the y-intercept would shift up 3 places and end up there. And so what you'd see if you tried to draw it is that you actually only had 1 point, which your maths teacher is not going to consider accurate enough. And so if that's the case, we'll definitely plot that point, but we would need to work out another point. So I would advise you then substitute in something like this minus 2 here. So let's take this as if it were our equation, and we say y is equal to 2 to the minus 2 plus 1. and you'll see that gives you an answer. You can take that on your calculator of 1 1/4. So then you could plot quite accurately and say, well, at -2, we are dealing with an answer of 1 1/4 there. So you'd have your coordinates, and then you could actually draw that graph far more accurately than what I did there where I just guessed it. Okay, so please watch out for that. You're not always going to get an x and a y intercept, but you can substitute in some points or even use the table method, and you should be able to sketch any graphs. Okay, now we are asked to sketch the graph of g of x is equal to minus a half to the x plus 4. So loads is going on here. The first thing that we can do is we can look at that q value, and we can straight away say that's the asymptote. So let's draw that. It's always nice to know you've got at least one mark in the bag. So draw that asymptote, use a nice dotted line and your ruler, and then remember to label it. Okay, so y is equal to 4. Now let's have a look at what else this graph is telling us. We've got an a value here of -1, and we've got a b value of a half. Okay, so two things are going to happen here. If you picture with me what this should look like, and a b value of a half means we're having a decreasing function, right? But because it's now a negative, it means we're actually going to flip that over. We're going to have the mirror image on the other side of the asymptote. So we want to end up with something that looks like this red line here, somewhere here. Okay, let's plot some intercepts. Okay, it's really helpful to just understand what the graph should look like, so that once you've plotted your intercepts, you can identify, is this correct, or have I missed something somewhere? Should I go and double check my answers? Okay, let's get an x-intercept by letting y equal 0. So we're going to say here 0 is equal to minus a half to the x plus 4. Okay, let's take this minus a half to the x over, because it's going to become positive. So we end up with 1 over 2 to the x equals 4. Okay, now it's an exponential equation. I want to end up with same bases. Now 4, I can write that as 2 squared. But this other fraction here, I'm going to have to just think a little bit about. Okay, so if something is written as a fraction, it means it actually had a negative exponent outside of that fraction. So let's make that 2 to the minus 1, and that's all being raised to the x. So this is actually just 2 to the minus x is equal to 2 squared. And so therefore, x is equal to minus 2. I can plot a point over there. All right, and then I want a y-intercept. We're going to let x equal 0. So we end up with y is equal to minus a half to the 0 plus 4. Remember, anything to the 0 is actually just 1. So minus 1 plus 4 is 3. There's my other point. Okay, now having a look at this, what we were saying earlier is it needs to be decreasing, but then actually a mirror image because of the negative. That's true. It is going to have that shape when we plot it. So let's do that now. There we have the graph of g of x, and check that all your intercepts are labeled. Check that your asymptote is labeled. If you worked out any other points, make sure they are labeled too. Right, let's see if we can determine the equation if they give us a graph. So here, I can see this is an exponential graph. Another thing that is a big guide for me is this asymptote over here at y equals minus 6, okay? And there isn't another one here. Remember, if that was a hyperbola, there would be more arms and more asymptotes, okay? So the first thing we do when we are asked to determine the equation is we write down the standard form. So we saw earlier, y is equal to a times b to the x plus q. Okay, now what we do is we sub in the asymptote. All right, so the asymptote there is minus 6. So we're going to write y is equal to a times b to the x minus 6. Okay, now if you look at this, we are given these coordinates. They're both intercepts, but definitely my advice to you for step 2 would be to sub in this y-intercept first. Okay, because x is 0 and that becomes very easy to work with. So you can substitute this point in first, but most of the time they give you a y-intercept and that makes life a lot easier. So in the place of y, minus 4 is equal to a times b to the power of 0 minus 6. Okay, that actually, a times b to the 0 is a times 1, so just a. If we move the minus 6 over, we end up with positive 6. So minus 4 plus 6 is 2. Okay, so that means we now know that we've got an equation that says y is equal to 2 times b to the x minus 6. Okay, and that leaves us then with one more point to sub in. So the other point there is 1 and 0. So 0 is equal to 2 times b to the power of 1 minus 6. So that ends up being 2b, let's take that minus 6 over, is equal to positive 6. And divide both sides by 2. And so we end up with b is equal to 3. So there we have a nice little answer. We know the q value, we know the a value, and the b value. So we have worked out the equation here. Therefore, y is equal to a, 2, times b, 3, to the x, for exponential graph, minus 6.